Right, this lesson, we are looking into parametric differentiation. Quite a really short lesson, only one example, two examples, quite a short one, because in terms of differentiating parametric equation, there's not a lot of skills. What you have to know is obviously the chain rule, product rule, and quotient rule. You have to use them really fluently in order to differentiate anything else. So this just on top of it. So parametric differentiation. So we remember parametric equations are a pair of equations where x and y are in terms of a parameter t. To differentiate a pair of parametric equation, to find dy by dx, you don't have to work out the Cartesian equation. For example, in here, you don't have to work out Cartesian equation. If I want to differentiate it, I can just do dy by dt divided by dx by dt. So I'll show you how to work out. Example, find a gradient at a point P where T is 2. So we know to work out gradient, the gradient gives away to do dy by dx. Okay? At a point where T equals 2, or the curve given parametrically by that. So to differentiate parametrically, I can do dy by, I know dy by dx equals dy over dt divided by dx over dt. So I just have to differentiate x and y separately. So let's do, so dx by dt, okay, differentiate x in terms of t is t cubed is 3t squared plus 1, then dy by dt is 2t. And then you do dy by d, so dy by dx equals to dy by dt, which is 2t divided by 3t squared plus 1. So at t equals 2, the gradient dy by dx equals to 2 times 2 over 3 times 2 squared plus 1. Put in calculator, 4 over 13, that's a gradient. Okay, that's it, done. Next one. Example, find the equation of the normal. Equation of normal. So equation of normal, a bit of a revision for you. To work out equation of normal, you need to use y minus y1 equals mx minus x1, or you can use y equals mx plus c. You prefer the GCSE way. What you need, both of them, you need two things. You need a point, coordinates, x, y, and you also need a gradient, okay, which is dy by dx. And because it's normal, we need to do negative reciprocal as well for the normal. Negative reciprocal, can't spell. Right, so let's do it one by one. Let's work out the gradient first, the dy by dx. So work out dy by dx, because this is in parametric, so we need dy by d theta over dx by d theta. It's not dt because theta is your parameter in here. So we'll do dy by d theta. 5. So we'll work out dx by d theta is differentiate 3 sine theta. Differentiating sine becomes cos of 3 cos theta. Dy by d theta, differentiate 5 cos theta is negative 5 sine theta. Negative 5 sine theta. Okay, so therefore dy by dx equals negative 5 sine theta over 3 cos theta. We know sine over cos could be written as tan theta. So we're given theta is pi over 6. So let's sub it in. When theta equals pi over 6, then dy by dx equals to minus 5/3, 10 pi over 6. So you put in the calculator, you should get negative 5√3 over 9. Now, but this is the gradient of tangent. So therefore, the gradient of normal, if you do negative reciprocal, then m of normal equals negative reciprocal is 9 over 5√3. Put in the calculator, you will get 3√3 over 5, because the calculator will have you rationalize and simplify for you. So yeah, so 3√3 over 5, that's our gradient. Sorry about the glitch on the board. Yep, 5. So we need a point. Next, we need a point. So we've got the gradient now. So one of the checklist, done. Next, a point. Okay, to find a point, we need a point is x and y. We're given theta value, so to find the x and y value, then clearly you need the x and y equations. So we can sub in the theta value into the x and y equation to find the points. Okay, so next we need a point. So we know x equals 3 sine theta. So x equals 3 sine pi over 6. Put in the calculator, you get a 3/2 or 1.5. Y equals 5 cos theta. So y equals to 5 cos pi over 6, which is 5√3/2. So using the equation y minus y1, so y minus y1, 5√3/2 equals m, which is 3√9, 3√3/5, sorry, times x minus x1. I'm going to make y the subject in here, so I'm going to expand the bracket on the right-hand side and move the minus 5√3/2 to the right-hand side. So expand the bracket and then add to the other side. So y equals 3√3/5x. And then if you put in a calculator, you get 8√3/5 as your final answer. Okay. And that's it really. Okay, so in a homework where you will see different lots of questions about parametric equation, in terms of differentiating parametrically, it's just dy by dt over dx by dt. However, the y equation and x equation could be slightly more complicated. For example, you need product rule or quotient rule sometimes to do it. But that's the end of 9.7, parametric differentiation.